Hi friends, today we are standing at the VIT Business Incubator Center. Today myself, Kevin Thomas, and my friends Mayank and Abhimanyu, we are going to speak on the topic rapid prototyping. Especially we are going to spread light on the topic fuse deposition modeling. This fuse deposition modeling method was founded by Stratasys, and it's a very relatively new topic, just founded 20 years ago. This method has revolutionized the area of rapid prototyping. You just think of anything and you just think of printing it. Fuse deposition modeling, like all other rapid prototyping processes, is an additive form of manufacturing process in which we create layer by layer, fixing one layer of the other. The biggest advantage of this process is the material saving. Like all other subtractive forms of manufacturing, we lose a lot of material. So biggest advantage is the material saving. Whatever material we are using it in the product. So let's explain the working of this fuse deposition modeling. So 3D printers that run on FDM technology build parts layer by layer from bottom of technology. We build the bottom first and then we move up till the end. So whatever slicing of the material is done in the software. Like if we have a 25-meter high prototype, what we'll be doing is that we'll be making slices of around 0.25 meter. So we'll get around 100 or 101 slices. So the material used in this is thermoplastic filaments. So the first process used in this is the pre-processing. Like I told, in the pre-processing process, we are building the 3D CAD model of the process and we are slicing it into different sections of required cross-sectional area. And just think of anything that can be fitted inside this machine and you can just print it. The FDM process capabilities are very high. Just think of anything which could be kept inside this machine. You can just print it. It's very much simpler to rapid prototyping technique in which we just make layer by layer and just print it. Then we calculate our path to extrude the thermoplastic material, and in order to maintain the shape we also have a support material that runs parallel through it. So the second process is the production. Now as we move into production, what happens is that the 3D printer has heating coils throughout the process that heats up the thermoplastic material, and that also heats up the support material that runs parallel through it. Usually the support material is a weakened material which can be easily rubbed off through chemical or by washing itself. But the main material is the extruding material that is heated up, and the path is calculated actually by the computer itself. This process, there is no need for manual members also, because everything is manually operated, and the thing is that we are tension free. We just have to operate the run button in the computer and it will run. After the production process, what happens is that the post processing, there could be the support material that hangs in over the object, like there will be many overhanging parts in the object. So the beaker material, which is support material, supports it to the ground. So our main aim will be to remove those parts and wash it away or chemically remove it.
Hello friends, I am Abhimanyu, and as my friend have explained about the FDM process, so now we will go by machine. So this is FDM Titan, and this is made by Stratasys USA, and as I say, the model is FDM Titan TI. The bed size is 406 into 355 into 406 mm. The materials are ABS, ABSI, PC, PC ABS, PC ISO, and PPS. So the unique feature of this machine is versatile through an RP platform and multiple high performance materials, powerful infrared software, and office operation with no special venting. So it is easily upgraded to handle future materials, and this Titan uses the patented FDM process and revolutionary waterwork soluble support for ABS material. and it allows us to dissolve the temporary support structures with water rather than manually handling them or by using solvents. Inside software makes this building durable and functional. Prototype parts as easy as sending a CAD file from your workstation to a Titan. So just simply plug it in and connect it to your workstation and on network. So the working temperature for ABS is 90 degrees Celsius, and for PPC is 145, and for this PPSF it is maximum, that is 230 degrees Celsius, and it is the maximum temperature it can handle. So this machine is dimension, and the bed size is 203 into 203 into 305 mm, and the materials it can handle is ABS thermoplastic, and the thickness is 0.33 mm. The wall thickness it can obtain is 0.6 mm. So as we can see, this is the RB platform, this is the build platform, and this is the connecting rod, and it comes from top to bottom, and then the part is manufactured. Yes, we can see. So this machine is Pro DV, and the build size is 203 into 203 into 305 mm. The materials is ABS thermoplastic. The thickness is 0.1778 mm. The wall thickness is 0.6 mm. So that this system builds models including external features quickly directly from CAD STL files. So the acceptable file formats can be obtained from AutoCAD, CATIA, iIdeas, ImageWare, and this SolidAs. So the format in which all these files are sent to this 3D printer is .stl. So this file format actually just shows this geometry only without showing the colors and textures. So in this, the main part is the orientation that we have to decide in the beginning of the process. So first, as we can see, how we can select the orientation is how we want this product to be look like. So as you can see.
Now we are moving on to the main part of the process. Whatever we saw now, it's only what the computer does it, and that computer is here. The software we using here is the Insight software. In that, the first process is taking the part from the part file, importing it to the software, and then there could be innumerous number of orientations possible. So we have to choose that orientation in which the overhanging parts are less, and we have to see that the orientation itself will decide the aesthetic look as well as the strength of the material. So we have to see that less support in an orientation in which less support material will be used. So in this, we are taking the bottom plane and we are going to select it. Bottom plane we'll select, and the bottom plane is going to be selected now. So this will be the orientation in which the part will be built. So this is the easiest way that will reduce the staircase effect, and the material will have a smooth covering or the smooth finish to its surface, and the aesthetic look will be the maximum in this orientation. So the next process is slicing. So here we are going to slice along the Z axis. So we select, now we can see the small slices, and the slice thickness will be around 0.2540.
Hello friends, my name is Mare, and as my friends have already told that what are the basic principles of this machine and what are the kinds of machine we have here. So now I am going to tell about the type of material we are using in this machine. So first of all, what are the type of materials that when we have used here? One is the ABS, that is acrylonitrile butadiene styrene. That is a thermoplastic polymer. It is mainly suitable for functional applications. As we have seen that injection molding, where we use the ABS material, but in case of FDM, the strength we get is the 80% of injection molding. So second material is the ABSI. It is basically the part of ABSI in which we get a high strength impact. So the third type of material is ABS M30, which is also part of ABS, in which we get 25 to 75 stronger than the normal parts. It is used for making a smooth part and have greater fatigue for strength. And the other materials we use are the ABS, ES, DA, PC, ABS and PCH ISO. So now we can see the material for the base. Here the base material is here, and on which the first layer of the material is scanned. This is used for the machine, dimensioning machine. And second one is the FDM Titan, in which the base material is a thermoplastic layer, in which also the first layer of the product is manufactured. And
so guys, now we are going to see the delivery system. This is actually the cartridge from which is fitted actually inside these things. So in this, what happens is that it's a one-time use thing. So this is actually a support material, which is actually the weaker material, and it's like a plastic thing only. So when this material finishes, this thing is thrown out. So every time we need a new cartridge for the process.
The major defect in the FDM process is the stereochase effect. So in this effect, due to this effect, the surface finish of the products formed are less. What is stereochase effect? So the XY plane, the products formed are very good in the XY plane. But as we know, this is the layer by layer process. So if one layer is deviated from its part, then all the layers are dragged, and so there is a deviation in the Z axis. So due to that, surface finish is not good. That can be increased by post-processing process, like by polishing, by grinding.
Another big defect of this process is that we need build material. For every process there is a build material needed just to support the product. So every time we need an extra material, so which will add to extra cost. So friends, this is all about fuse deposition modeling. We are currently at the VAT Business Incubator Center in the TT building. This has a capacity of about 3 machines, one big machine and 2 small machines, which cost, this machine is a Prodigy machine, which costs around 50 lakhs, and this machine is the Dimension one, which costs around 50 lakhs again. And one more machine we have is the FDM Titan machine, which costs around 2 crores. So whatever products they make here is used for commercial purpose, but students are always open here for research purposes. So thanks a lot.